Here in this video, we will discuss about process controlling concept. Process control that includes process identifiers, fork function, and file sharing, and supposed to explain other properties of how inherited properties inherited by the child process. Whole thing we will discuss in this video. Here in this slide, we are discuss about process identifiers informations. Every process has a unique process ID, nothing but process identifier. It is a non-negative integer, means it contains only 0 and positive integer values only. And then we will discuss about a few different types of process identifier. Those are called special processes. First one, process ID 0. It indicates scheduler process, also known as swappers. Scheduler process means which one is the started initiated process are there. That process is called scheduler process, and sometimes it is also called a swappers. Second type of special processor are called process ID 1. Here init process, nothing but initiation of the process, and then it never dies in any situation or any circumstances, and it is a normal user process. Normal user process run with super user privilege. Run with super user privilege. And then third one, process ID 2. This is possible to provide page daemon informations. For that we are using the prototypes for process identifiers to get the information of ID, to get the information of process ID, to get the information of user ID, to get the information about execution of user ID, to get the information of group ID, to get the information of user ID. Like that we can possible to generate these number of process IDs for completion of the process. Here we discuss about the fork function, how the fork function works, at what are the circumstances fork functions are required for execution of the process. The only way a new process is created by Unix kernel is when an existing process calls a fork function. Nothing but whenever required to run a new process, then only we can call the fork function. The prototype of fork function, that is PID fork with no return value, that is the prototype for the function. That requires to include header files. One is system types.header file, one more is Unix standard header file. And one point to remember, at the time of execution of fork functions, the new process created by fork is called the child process, right? The function is called once but run twice. Nothing but whatever new process is created for running the child process, for that only we can call for function. When that function is called, it should be only once it called, but it's supposed to return 2 times the value, right? And then the return value in the child is 0 when the child process starts. Return value in the parent is the process ID for the new child. When the process started, new process ID is generated. Then the child is copy of the parents. Always remember the information about start the execution of the fourth one. Then that automatically consider the copy of the parent of information should be transferred to the child. And then next one we have discussed about child gets a copy of parent text segment, data segments and heap and stack information. Nothing but whatever the information that should be carried out from the parents, or the memory allocation for text, memory allocation for data segment, memory allocation for the heap when the dynamic information or dynamic allocation of the information should be performed. Otherwise, when the swapping of things should be done, we can call it stack memory. For that, we are supposed to go for get the information of these information from the parents. Then instead of completely copying, we can use COW, but copy on write techniques, right? We can suppose to go for using copy on the write technique. Here the figure scenario that shows one is for function, how for function initiated the work. Second one is child process, how child process initiated for starting a new process. Here the program that possible to display the information about external variable in initialized data, and also which are all automatic variables on the stack on the time of running the program. And also it generates any error is there, that's up to go for display and fork error. Otherwise it generates process information ID, that is when PID is equal to 0, then the display the information about the process, the display child identification number, and also what is modifying of corresponding child identification process, that also display. Otherwise it's supposed to go for take some time to sleep, and then it want to go for process, print the information, what is the process ID, what the information about modified variable globe ID. Otherwise it display the what is the variable information, the child information, and also what is get process identification number also it display. Then that automatically terminates when the exit function is called. Okay, this is a simple program how the process is created, how the values are stored in the stack, when it called, how the process ID is generated. Otherwise what is the error should be generated by the fork function, that should be identified and displayed. Here first one you check if write the corresponding standard output file should be called with buffer size of buffer size with the -1, and that display the size of the buffer -1. Nothing but it should be display the information of what is size of the corresponding buffer. If it is true, then display a write error and print before four things should be executed what information is required to go for print. On that time it generates the process identification. Once again check if it is PID is equal to 0, then only the child process is executed. Otherwise, it is supposed to print the parent information about the process. Here in this slide, what is the output of above program when the program is run? You type ./a.out that display the output of the above program, and then a write to stdout header file is called, and that information supposed to execute, condition supposed to work. Then it supposed to print before fork what information is there. Process ID is 330. Okay, global information is 7, variable is 89, nothing but child variable where you want to go for changing it. Then process ID is 429, global is 6, variable is 88, nothing but parent copy was not changed. The previous process ID is 429, next ID is 430, nothing but this is the previous one. When new process is started by child, next process number is generated. After 429, 430 generates. Whatever global information is, that should be changed by 6 to the 7. Next information should be hold, and then whatever the value should be hold in the stack 88 to the 89. That information printed. Okay. Do you want to go for print the same thing? Then you want to go for using greater than symbol, write the file name .out. That prints when you type the command cat temp.out, that displays the same whatever the previous value is there, information should be hold possible to printed, same thing should be displayed as printed. A write to call from the standard output file before fork PID is 432, then global variable is 7, variable is 89, then before fork it's supposed to go for started, the parent ID is 431, global ID is less than that 6, and variable is supposed to consider is 88. Like that, information is possible to go for display when the above program is executed. And also we have discussed some points about file sharing of the information. Here fork creates a duplicate copy of file descriptor opened by the parents. Okay, it's supposed to generate, parents are created, whatever the same information, the cloning of the parents information should be copied to the child from the child descriptor. And then there are two different ways of handling the file descriptor after the fork function executes. One is parent waits for a child to complete. Second one, after the parent closes all the descriptors that does not need and does the same thing, that's supposed to go for display. Nothing but the file sharing thing should be done whenever anything is copied, duplicate or clone of the parent thing should be copied only when the child process supposed to create it and same file descriptor pointed to the next values. Okay. Uh, Here in this slide we have discussed some of the properties inherited by a child process. Besides open a files, the other properties inherited by childs are discussed here. First one is real user ID, group ID, effective ID and effective group ID that's supposed to generate it. And then supplementary group ID if it is required, that's also generated. Then process group ID is supposed to generate same fashion what is the session of ID that also displayed. Here controlling tunnels whatever required to go for manage and control the execution of the process. Then you want to go for set the different types of IDs. One is user ID, one more is group ID. That should be set by using UID and GID the process. descriptors. Then current working directory, which is the current working directory about that process, where the information is held, how that should be carried out. Okay. Then you want to go for display the same thing by rout directory that display the informations. File mode, creation, mask. If anything is required to file operation, where what operations are masked, which are all the operations are unmasked type of, that mode should be set with different values. Then signal mask and dispositions, nothing but whatever the positions are changed, that's supposed to go for identified and display. Finally, a close on call exit function or exit flag for any open file descriptor. Nothing but we can call the corresponding file descriptor function, thus supposed to go for close the execution of the corresponding process identified through close on execute flag supposed to call. Then we move towards environment of the informations. What are the different types of environments are there to run the process, to run the child process? Attached shared memory segments, which are all the memory segments are there here. Stack segment, heap segment, right, temporary segments. Okay, after all memory locations allocated for that, all segment informations also attached. Then resource limits are there, which are all the resources we are used to try to execute this function. All resources are uh, identified, and that supposed to go for using minimum utilization of those resources to run the process. Like that, when the for function that should be called a child process for creating a new process of information, then automatically these properties are inherited by the child from their parent process.